Right, this is going to be the homework help for 4.1, the rectangular coordinate system, making sure you can plot points, and when you see points plotted on a coordinate grid, that you could write those as ordered pairs. So let's look at number one. We have the point -4, 2. Recall that this first coordinate is the x, and the second coordinate is the y. And for now, we can just say always. So one way we can do these is just go ahead and, if you're not provided a grid, just go ahead and draw one out as best you can. There's x and there's y. And we can go ahead and label. I'm just kind of glancing at my points here. Looks like I don't have anything bigger than 5. So if I can come out to 5. A little messy, sorry about that. And then I can 2, 3, 4. I don't think I go above 4. I got 5. Okay, so I went ahead and labeled that out to 5 on both sides. And let's see this first point, -4, 2. So some students will mistakenly just plot x equals -4 and go down -4 and put a dot and then 2. That's not how this works. This is one coordinate, so this is one point. So when it's written this way, again, when we have whatever the numbers are, x comma y, that defines one point. So here -4, 2 is going to be over -4 and then up 2. Right there. And so you could write this as -4, 2. How about this next one? -1, -2. So I'm going to go over -1 and then down 2. And that's that point. I'm just going to label that point B, because it labels with that one. How about point C? 3, -5. So I'm going to go over 3 on the x and then go down 5. So that's point C. How about point D? -3, 5. So going to go over -3 on the x and then up 5. And that's point D. And the last one, we have 5/3, 2. So 5/3 is about, well, it's exactly 1 2/3, so about 1.7, not quite 2. We're just going to estimate here. So there's about 1.7, and then we're going to go up 2. So 5/3, 2. That's point E. Now, better, of course, if you can use a coordinate grid. So for instance, I might not do all these, but -4, 2. Well, I have -4 and then up 2. So that's that point. -1, -2. So over -1, down 2. So a little bit easier if you're given the grid already. And maybe I'll do one more. Let's see, 3, -5. So over 3 and then down 5. So that's 3, -5. All right, so that was number 1. Now, number 9 on the homework. Here, we're kind of given the opposite. Now I'm giving you the grid, and you need to be able to write the points as ordered pairs. So let's just do these in order. Here's A. So point A is going to be what? It's always the x coordinate first. So again, recall, it's always x comma y every time. So it's going to be -4, comma, up 1. What about B? So point B is -3, -4. How about point C? Going to go over 1 and down 3. And finally, point D, is 4, 3. One other part it doesn't ask for here, but we ought to be able, oh, actually it does, identify the quadrant that each point is in. So this is quadrant 1 in the upper right, and then this is quadrant 2, quadrant 3, and then quadrant 4. And we just traditionally use Roman numerals, I guess, not to get them confused with the numbers on the number line or the coordinates. So for instance, this point here, point A at negative 4, 2 was in quadrant 2. Point B is over here in quadrant 3, and so on. Okay, so make sure you can identify the quadrants. Okay, let me do just one of these. I'll just do 13. So the following exercises, which ordered pairs are solutions to the given equations? So you're given an equation, 2x plus y equals 6 in this case, and we want to know which one of these, or more than one, satisfies that equation. And so we're going to take this point, first point 1. Again, if it helps, just takes an extra second to write in x comma y or xy, just remind yourself, 2 times 1 plus 4, is that equal to 6? Well, yeah, 2 times 1 is 2, plus 4 is 6. So that point definitely satisfies it. I'll just go ahead and circle that. How about the next point? Point B. So there's point A. How about point B? So point B is 3, 0. So 3 plus 0 equals 6. 2 times 3 is 6, plus 0 is 6. So point B also satisfies it. How about point C? 2 times 2 plus 3. Is that equal to 6? 2 times 2 is 4, plus 3 is 7. That does not satisfy it. So only those first two coordinates satisfy this equation. So similar to this, now we're going to be given a few coordinates for x, and we want to find the coordinates for y. So here's our equation, y equals 2x minus 4. So we're just going to plug 0 in. So in this case, we're going to say y equals 2 times 0 minus 4. 2 times 0 is 0, minus 4 is a minus 4. And it's asking you here, write this as an ordered pair, 0, negative 4. How about 2? Y equals 2 times 2 minus 4. Well, 2 times 2 is 4, minus 4 is 0. So my next point is 2 comma 0. And then they've given me one more is negative 1. So all I'm doing is plugging in these values for x to see what I get. Oop, left off my 2. So 2 times negative 1 is negative 2, minus 4 is negative 6. So negative 1, negative 6. So we will often choose 3 points or coordinates when graphing lines because you can always draw a line through any 2 points. And so that third point is often a checkpoint. Now, when you get pretty good at these, all you really need is 2 points. I often don't force you to choose 3 values. Just make sure that you know what you're doing when doing these. Okay, and maybe I'll do one more. Because later on, the next step of this is going to be to plot these points and draw a line through it, just sort of foreshadowing what's happening. Okay, so now they've given us these values. So when x is 0, notice that 0 is always a great value to have. The math is pretty easy relative to other numbers. So when I put a 0 in for x plus 1, 1/3 times 0 is 0 plus 1 is 1. Not a coincidence that it's that value right there. So here's my point, 0 comma 1. Now, why do you think they skipped and chose 3? Well, because the 3 is going to make it nice. Because when I multiply 1/3 of 3, those 3's cancel, and I'm left with 1 plus 1, which is 2. You know, if I'd picked a 1 or a 2 there, I'd end up with fractions, and I have to get common denominators and add those together. I'd prefer not to do that. And similar, this is why they chose 6. I'm trying to choose multiples of my denominator. So I'd want to choose numbers like -3, 0, 3, 6, 9, things like that. So be nice to yourself on these, times 6. So 1/3 of 6 is 2, plus 1 is 3. So my next point is 6 comma 3. Okay, so let's just do one of these. Maybe I'll pick number 35. So in the following exercise, find 3 solutions to each linear equations. So I'm going to make my own table, and this is generally what you would need to do. They're not going to give you the x coordinates. You got to pick them. So 0 is always a good value to choose. Can't think of a single instance where it's not. So when x is 0, what is y? Now I'm showing what I'm doing here. You don't have to do this, especially with 0. Pretty easy to do in your head. Because negative 4 times 0 is 0, you just get a 5. In fact, when they're set up this way and y equals mx plus b, it's always that constant term because that term always goes to 0. Okay, what's another number you want to pick? Well, no fractions here, so no big advantage. I'm just going to choose a 1. So y equals negative 4 times 1 plus 5. So negative 4 times 1 is negative 4, plus 5 is 1. And we want to find 3, so let's pick one more. How about 2? So y equals negative 4 times 2 plus 5. So it's going to be negative 8 plus 5 is negative 3. And I just want to make one little connection for you. You don't have to see this quite yet, but notice as I'm going up by 1 each time. What happens here? I'm going down by what? From 5 to 1, I'm subtracting 4. From 1 to negative 3, I'm subtracting 4. Do you see where that minus 4 is in the equation? Right here. That's not a coincidence. I'm just going to throw that out there for what it's worth.